Tuesday. Hopefully your day's off to a good start. If you are at this point in your day with math, this means you have done Tuesday's Fantastic Five. Hopefully you saw that score go up from Monday. Hopefully you watched that review video to help you maybe figure out any mistakes that you might have made. And if you have done Fan 5, that means you're going to be familiar with what you're going to see today. So yesterday we talked a little bit about data, which we're going to keep focusing on data, but we focused specifically on whether data was numerical or categorical. And just to recap, we said that anything that you can measure, like height or weight or time, anything that's going to be answered with a number, that's going to be your numerical data. And anything you can answer with words, favorite sport, favorite color, any of those things, that's going to be your categorical data. So we're going to focus on gathering data for a couple of different questions today. All of them are going to be categorical data, and it's going to be a little different through the computer because in class we're actually going to collect real data, which we can't just do it with me talking to the computer. So what I'm going to do for our data is I'm going to give you the data. We're just going to make up some numbers so we can actually do what we want to do. But we're going to be looking at frequency tables today, which you saw in your Fantastic Five tally charts. And we're going to be able to take data from a frequency table and put it into a bar graph, which I would assume you guys have probably had some prior experience with in school. I'm not as much focused on making the bar graphs. I'm more focused on answering questions based off of the data, which we will get to. And you don't have any independent practice or homework tonight with this, but what you do have is a little exit ticket. And it's just going to show me if you have a basic understanding of what we're going to talk about today. So moving forward, the question is asking, what does a frequency table look like? Well, you just saw those in Fantastic Five. It looks like a tally chart, right? And this is actually the same tally chart, or I'm sorry, I'm just trying to say frequency table. Same frequency table that you saw in Fantastic Five. It's measuring people's favorite type of chocolate between milk, dark, and white. And the question is asking, what does frequency mean? And you may have heard your parents or people talking about using that word just in everyday conversations. Doing something frequently describes how many times you do it. Like I like to say, I eat at Sup Dogs frequently because me, my wife, and Charlie, we go there pretty often. So frequency is just telling you how many times you see something. So this is where in class, we're going to look at this question. We're going to ask the class our favorite colors. And we're just going to give them choices because you could go all over the place, but with such a little class or such a small class size, giving them choices, they're just going to have to pick one of these. So if we're asking favorite colors, would that be numerical data or categorical data? That would be categorical data because, again, I'm answering with words here. So I am going to come back to this screen once we make this bar graph, and we'll add some tallies, and we'll just come up with the data off the top of our head. But I do want to show you that this video is actually linked in your announcement, so I'm not going to play it in this video. It's not going to tell you much differently than what I'm going to tell you, but it's a great video if you want an extra resource or a little bit of extra practice with bar graphs. That is linked in your announcement, I believe, at the very bottom. So I'm going to show you a picture of a bar graph. And it's a little bare. It's missing a couple things. So you may notice that it's missing labels. It's missing some things at the bottom. And I got some questions here that you could answer. And really, you can answer this based off of what it gives you. It says, what do you think the question might have been that was asked of the class? Because you don't have any categories down at the bottom. But if you look at the title of your graph, which every graph should have, it's very clear that the teacher was asking the students, what are some of your favorite things? And before we go into the actual bar graph with everything you need, I just want to talk about some words that you're going to hear. We've talked about them already, but we talked about data yesterday. We're going to keep talking about it. And remember, that's just information that you can collect. You can gather it by asking questions, observing, or measuring. Frequency table, which you just saw, you've seen it in Fan 5. That's just data we're collecting, and we're showing that through tallies. The scaled bar graph is what we're going to look at in just a second, and we're going to create. and we're going to use the same data. We're basically taking the data from the frequency table, and we're just putting it into a bar graph. And every bar graph has to have certain things, which you'll see in just a second. And we talked about categorical data, and this would be an example of that. I feel like I went through that kind of fast, but again, we talked about this stuff before. The beautiful thing about this video is hit rewind if you need to, go back and listen again if you think that's necessary. So now we've got a little bit more information with this bar graph. If you look at the title, it's measuring the favorite drinks. You've got your choices down at the bottom. They were asking between Cheerwine, Coca-Cola, iced tea, and lemonade. That's no-brainer for me, lemonade in a blowout. And you've got your scale over here too. You've got how many people voted. And if you look, it goes from 0 to 10 to 20 to 30 to 40 to 50 to 60. Counting by tens is going to be your scale. And one of these questions will come up in just a second. They don't all fall exactly on a line, but we can still get some, make some observations based off of this data. For instance, this first question says, which drink was the most liked? Just eyeball it. If you look at those bars, clearly the most popular drink is going to be iced tea. They must have asked students in North Carolina. Similar to that last one, just the opposite. Which drink was liked the least? And it's a little bit closer than the other question was, but the least liked drink was Cheerwine, which is kind of surprising. This one asks, can you estimate how many people voted? And the answer to that is yes, because we don't know exactly where this falls. Same for every other bar. They don't fall exactly on a line, but the way that I do this is, first I got to know what my scale is, okay? I know my scale is 10. So I know halfway between 50 and 60 is going to be at 55. Right here, I know halfway between 10 and 20 is going to be 15. Halfway between Coca-Cola, or between 20 and 30, I'm sorry, is 25. And lemonade's halfway would be between 10 and 20 would be 15. So if I'm just looking at, and let me see if I can get my marker here. If I'm just looking at Cheerwine, and I'm looking at that, that doesn't quite get to halfway between 10 and 20. Okay, it's close. So it doesn't quite get to 15. I would maybe put that at 13 or 14. So I would estimate that's at about 14. All right, if I'm looking at Coca-Cola, between 20 and 30, that doesn't make it to halfway. So I know it's less than 25, but it's got to be more than 20. For that one, I might say 22. Again, an estimate is a close guess. Iced tea, it's got to be more than 50. It's got to be less than 60, but it doesn't quite get halfway. So again, I know it's not 55. I'd maybe put that one at 52. And I want you to come up with what you think lemonade would be. Look at where it's between, the two numbers it's between. Think about what halfway would be. See if it's more or less than that, and then kind of make your observation. So I know it's more than halfway. It's going to be more than 15. It's not quite 20, but it's pretty close. I might put that one in at 19. So if it's asking, could I estimate that? Sure, I could. I could round those numbers. I could round them to the tens, or I could just take those estimates that I just made, add those together. It's not going to be exact, but it's probably going to be pretty close. How do I get that out of here? Mouse. I'm going to figure this thing out eventually. All right. It says, the last question, it looks like more than twice as many people prefer iced tea than Coca-Cola. It asks if it's true and how we can find out. Great question. And this is kind of reminds me of a question that I would maybe do on a Fan 5. So let's go ahead and do some estimates. Let's round these to where they're close to. So iced tea looks to be at about 50, right? I think we said 51, 52, I don't remember. Lemonade looks to be at about 20. Or is it Coca-Cola? I'm sorry. Coca-Cola. Coca-Cola, well, still about 20. How about that? Coca-Cola is at about 20. So if you want to know if lemon or iced tea is as twice as many as Coke, twice as many is important. Because if you're sitting at home and your mama asks you to do something twice, that means she asks you to do it 2 times, which looks like this. She only had to ask you once, but 2 times. That means I can take that Coca-Cola, do 20 times 2, and see if it gets me to iced tea, to see if that statement is correct, because it's saying it's more than twice. So let's do that Coke times 2. I'll show you a couple different ways to do that. This is the standard way we're going to be doing it. And I'll be honest, I'm not sure in 3rd grade if you did the 2 by 1 and the 3 by 1. But you set it up just like this. You got your numbers stacked. Bigger number's going to be on top. Place value lined up. All right, so I start by going 2 times 0. Well, 2 times 0 is 0. Boom. And I go across. 2 times 2 is 4. So that answers my question right there. It is true that iced tea is more than twice as many because iced tea was at 50. And when we did twice as many Coke, it was 40. So that is an accurate statement. Another way that you could have done, that multiplication, and this only works if the number ends in 0. I could set it up like this. I can kind of ignore that 0 and just do the basic fact of 2 times 2 and get 4 and add that 0 at the end. That's something we'll get to down the road, but just a couple of different options of how you could have added or multiplied those 2 numbers. All right, moving on, back to our favorite drinks. Here it's saying that it wanted you, in class what we're going to do is we're going to get with a partner or 6 feet partner, and we're going to come up with our own questions. Guys, there's really almost no limit to the amount of questions you can come up with when looking at a graph. I could say how many people liked iced tea, lemonade, and Coca-Cola combined? How many more people liked iced tea than Coca-Cola and Cheerwine? How many people like Cheerwine and lemonade combined? So many options that you could come up with. That's why this data, it's almost endless the amount of questions you can ask. So moving forward, if I can find my thing. There you are. You better get out of my way. So here is where we start taking the data that we're going to collect, which I'm just going to give you, and we convert it to a bar graph. So it's going to look like 2 completely different things, but it's using the same exact data. But in order to make a bar graph, you've got to have certain things. One being the title. That's the only thing that last bar graph had. You've got to have your labels at the bottom. That way you actually know what you're measuring. And you got to have the size label so you know what everything's representing. You got to have your scale we talked about on the side. And then you got to have bars. There's probably not going to be a very good bar graph if you're missing your bars. So what I'm going to do real quick is, I'm actually going to see if I can make this a little bit easier. If I can maybe get this. Oh, no, I don't think so. I don't know what I'm doing. No, check this out. All right, Mr. Huber, work your magic. Can I copy this? Oh, yeah. Watch me work. Let's get rid of this. Here we go. Yes. Surprise myself sometimes. So now that I've got the frequency table here, it's going to make us a little bit easier. Like I said, I'm just making this stuff up. There's that. Now, when we're doing tallies, you guys know that the 5th tally is supposed to go across. I don't think I can do that. But just know that these little clusters that I'm making are supposed to be 5s. Let's give red a bunch of votes. All right, so I'm going to make this a little bit bigger real quick. Looking at our frequency table, you've got your tallies, and then where we put the numbers is how many times we saw that number, or how many tallies that color has. So for blue, what number should I be putting? 4. For green, what number should I be putting? 13. For purple? 3. And for red, what should I be putting? 13. Very good. All right, so I'm going to make this a little bit smaller so we have room for our bar graph. Now, we know that that frequency table was gathering data on our favorite colors. So if we're going to start with a title, I think our best bet would probably be Favorite colors. I'm really hoping you guys can see that. All right, and then we need to have our labels at the bottom, which we've got our categories here. We've got blue, green, purple, red. Maybe I can spread that out a little bit. All right, and I'm running out of room, but I can say down here, these are my colors. God, I can't spell, can I? All right, over here on the side, now your scale is always going to depend on how much data you have. I mean, if you're measuring something, if I'm asking 40 people.
Miss Griffin or Miss Jackson, can you call the front office, please? Thank you.
If I'm asking 40 people, I might have something that has 31 votes. My scale was going to have to go a little bit higher, but my biggest number here is 13. I don't have to go that high. So I can stop at 13. I can make it go up to 15. It's really up to you. And then you got to know, or you got to try and figure out how many you're going to be jumping by. You want to count by ones, you want to count by twos, you want to count by threes. That part's up to you, because if with a number like 13 or a lot of odd numbers, your bars might not fall directly where they're supposed to fall. But what you can do is you can estimate, kind of like we did with the favorite drinks. So I'm just going to do it. Hopefully this will work. I'm going to go by twos. I think a lot of the graphs that we're going to deal with is going to go by twos, fives, and tens. So I know this isn't perfect. Not the best drawing there, but I know I can stop at 14 with my numbers. This is going to be my number of votes because my highest number is 13. Last thing you got to have with the bar graph is you got to have bars, and you can go different colors if you want to. It would make a lot of sense if we use the colors that we actually just said. So for blue, all we got to do is look at our frequency table and see that it got 4 votes. Take our bar up there. Boom. All right. For green, it got 13 votes. So it's not going to fall directly on a number, but I know 13 goes right in between 12 and 14. So I'm kind of eyeballing that one. All right, when it comes to purple, this isn't purple, but it's as purple as I got. It got 3 votes. Again, not going to fall directly on a number, but I know that falls between 2 and 4. And last but not least, red also got 13 votes. So that's going to match green. Oh, man. And it's going to fall in between 12 and 14. It's about as close as I can get it. So there we have a bar graph with everything we need. We've got a title, we've got the bars, we've got the scale, and we've got all the things labeled. And here is where you can come up with a boatload of questions, which I want to see if I can do this. I'm about to really test myself here. Disaster. So here's what we'll do. Let's go full screen. We're going to take our bar graph off. And we're just going to bring the tally chart over. So can I clear this? Drawings, there we go. All right, we're getting it. And I'm going to copy this again. Bring it over here for these questions. Now, these questions will have different answers depending on whatever data you have. I'm going to get it, I promise. I promise. I'll set it right here. All right, so that first question says, what is the most popular color? If you had your bar graph, you'd be able to eyeball it and use that, just use the bars to look. Here, we're just looking at our frequency table. And here you'd have actually, well, I'm not going to say that. Which color is the most popular using the tally chart down here? Kind of a trick question. That one actually has a tie between green and red. So you got 2 answers there. Number 2 says, how many fewer people chose blue than green? Key word there being fewer. So fewer should tell you got to subtract. And if we're subtracting how many fewer people chose blue than green, we know we got to do 13 minus 4, which I can knock that out right here. And in that ones place, you can see you've got more on the floor. So you got to go next door and get 10 more. This 1 changes to a 0. This 3 gets that 10 that I took, and it becomes 13. Now you might have to use your fingers a little bit, but if I did 13 minus 4, that would give me my answer of 9. So if 9 fewer people chose blue than green. All right, number 3 says how many people combined chose red and purple as their favorite color. So I'll give you a second to work on that. If you combined red, which is 13, and purple, which is 3, that would give you an answer of 16. And last but certainly not least, number 4 is a great question. It says, how many more people chose for blue and red than purple as their favorite color? How many more is super important. You're going to hear how many more 1,000 times this school year. You've got to know that how many more means that you've got to subtract. So I've kind of got this split. I've got how many more blue and red than purple. So I'm really combining blue and red. And then we're going to subtract the purple from it. So red's got 13 and 4 people chose blue. Okay, so if I added those up to figure out how many people that is, 4 plus 3 is 7, bring down the 1. That means 17 people chose for blue and red, which is how many more than purple? Purple had 3. So if I want to figure out how many more that is, I just got to go 17 minus 3. 7 minus 3 is going to give you 4. Bring down that 1, and that answer would have been 14. So again, we just made up that data on the fly. It still worked out with those questions. I think the main thing is, I know you guys know how to make a bar graph. The main thing is being able to look at data and answer questions based off of that data. So on your exit ticket, which is linked in your announcements, these questions and these graphs and frequency tables you're going to see, that's the only thing that you have to do after watching this video. After that, if you've got some time, you do need to finish your iReady diagnostic this week. It doesn't have to get done today, but you've got till Friday to get that done. So tomorrow, things are going to get a little bit more challenging. You're still going to use everything that you've learned in the last couple of days, but I think tomorrow is going to be a little bit more of a difficult challenge with what we have to do. So the videos are going to be super helpful. And remember, I am here on Zoom. If you need me, email me. I'm pretty easy to find, guys. So thank you for watching, and we will catch you next time.